retain the designer. The designer draws the project, projects it into the GIS, collects the GIS information, creates a CAD drawing, creates a conceptual design, loads it into the ArcPad, goes out in the field with the entire team there to observe it, revises and makes comments out in the field, revises that design, has another meeting out in the field, projecting the design, same team again, and gets revisions. And then the really useful tool of the design and the GPS, it can be issued straight to the contractor. The contractor then takes the design and incorporates it in his layout, his construction process, and actually running the location of his equipment. And one benefit that happened during this process is during construction there's always changes. Well, if the process is live and interactive, the changes can occur and decisions can be made in a short amount of time. One example I can give is there's a nice tree, and if I split the lanes, I can save the tree. Well, I could not make that decision before when it was on paper because I didn't know how much it affected the surrounding properties. I may reduce a property below a minimum requirement or something like that. But with all that information available to me out in the field live, I could make those decisions. So this is what the process looks like. Live field design is the interaction of the designer with the site and the surrounding environment. So it really takes it beyond looking at the computer screen and maps and so forth. It puts you out there interacting with the ground. This is one of the first units I use. It's a Dell, and that's a project that I'm going to get into right now. It's projected on the screen. That drawing was produced in CAD and exported to this unit connected with the GPS. So what you need to get this done, you need a trained GeoDesigner. That's what I found out that term's called. I've been doing it for 11 years, but you need to understand the process, and you need to make sure it works when you get out there on the site because it has a lot of technology to it, but it's a really useful tool when you get out there on the site. You need a scope for your project. These are normal items. You need to collect the best available data you can. GIS map and data is really useful. It's updated continuously. I have some data that I get that changes so often throughout the year that I'm not sure I have the latest data. So having live updated data is really beneficial in your design. You can supplement it with survey plats and more accurate information you need on the ground. And then you can input local design requirements. If you have buffers and setbacks, you're able with this software now to illustrate those in there and set up alerts when you enter those zones while you're walking around on the site, so you can be aware of where you're at and have your you export that either to ArcMap or ArcPad. Earlier I said that I used ArcPad, but lately I've been introduced to ArcMap and have a lot more capabilities with it. Both of them will take a GPS connection. It just takes a different type of computer to carry out there in the field. And then you view it with this development team. And one thing you probably did in your office, but you got to learn to do in the field is to direct the development team, ask the questions, and interview them to get the answers that you need to end up with a really accurate and useful design. Again, you can revise and check and create another design. This is an example right here of a recent design I did. It's titled as English Countryside Equestrian Community. It's in Tryon, North Carolina. It's a residential subdivision in an equestrian setting. These are the conceptual plans on this, and they were illustrated. It's a 33-acre lake in the middle. That's one of the main features. The other main feature is there's 160 miles of horse trails. So we went through this process that I described, and one thing I want to point out that ended up kind of unique that you can do is this is more of a typical subdivision layout. I'll point out something else on it later. But this side over here, as you notice, the buildings are in a very random pattern. All right, and let me speed through that a little bit, but that was an interesting story how we came about those. I selected the information for the design and put it together, and there's the plat, and there's the information you all used to see, and that was the first conceptual design, and it had problems with the views of properties through to the lake. After we went through that process that I described earlier, it was revised, and these are the conditions you see when you're out on the site. You see and feel everything, but you also have an appreciation for the natural features that are out there. This is a result of redesigning that, and what you can see is houses, locations were moved. They can see between each other. By the way, in the sketching, these bubbles represent 100 feet in diameter, so they're both a placement and a spatial tool that you use when you're out there on the site. You can move them around and make sure you have adequate space. So lot design is best suited for field locating the best site for buildings and infrastructure routes, for positioning the best views, orientations, access, and protecting natural features, and planning for green spaces and protecting the environmental. A lot of field design helps each field designer see how the design fits in the field. And there's a lot more to this. You can contact me later. Appreciate it.
So we can see a kind of broad definition of geodesign. Lots of people interpret it different ways.